Am I showing up as on there?
No, the screen.
Oh, just the screen.
On there. Looks good? Sounds good? All right, cool. Thank you all for coming tonight. This is going to be an extremely interesting talk for me. I know that AV has always been something that's a staple in cybersecurity, something that's a staple in anything that we do with computers for years and years. It has always been a staple. However, we all know that signature-based AV can be basically defeated by most 0 days out there. Heuristic AV is still learning, it's still figuring things out, and it has a different approach to this, but there's still things that get around AV. So I am super excited for Jesse to teach us about AV bypass and why your AV won't save you.
Cool, thank you. So this is Your AV Won't Save You. The alternate title is going to be AV Bypasses for Dummies by Dummies. They're all very basic AV bypasses just to kind of show some of the basic ideas and really explain what AV is looking at with all the different modes that it can run in. Throughout this presentation, we'll be using Defender and the Malwarebytes Premium AVs. So a little bit about me. I have my bachelor's from Davenport in digital forensics. So I enjoy spending time looking at like hex editors and things like that, which is kind of why I came up with this. I just enjoy spending way too much time on my computer. I have some certs like Security Plus, CYSA, and PNPT. Little table of contents. We're going to go through different types of AV, just so everyone's all on the same page. How to bypass some signature detections, bypassing memory, bypassing some heuristics a little bit, and then bypassing signatures the hard way, and then just some additional references if you would like to learn about any of this stuff a little bit more. So our types of detections, we have our traditional signature base, which is what AV has always been built around. We have our in-memory scanning that's usually done. And then we also have heuristic and behavioral analysis that is upcoming and still being built quite a bit. So starting off with signature detections, these are based around specific sequences of bytes usually. So whenever you drop a new piece of malware or a new file on disk, your antivirus is going to look at it and it's going to basically chunk it up, look for different strings that it knows are bad that are associated with common malware. If it finds any of those strings, it's going to alert you, right? So that's a lot of times when you're going to get false alerts on things, like you have a file that you just made and you put it on disk and then all of a sudden your AV starts going off. It's going to be because of a signature-based detection. Something in there just happened to hit some of those bad bytes that your AV is looking for. So signature detections, pretty easy to bypass since it is just looking for those strings. There's a tool called Threat Check, which we're going to be demoing here later, that automates the process for you. It makes it super easy. There's the link to it from Rasta Mouse on GitHub. The nice thing about signature detections, especially with larger antivirus tools nowadays, it's going to prevent most of the offensive tools or malware that you can just find on the internet from running. It's kind of just that going to stop anybody from just taking something off the internet and trying to infect you with it, right? Most things have signatures nowadays. If they're out on the internet. Both Microsoft, any major AV company has entire teams that are dedicated basically to just browsing the internet and finding new malware samples and then signaturing them. Next, we have in-memory detections. Pretty much works the same way as signature detection, but also running in memory. It's at the end of the day, it's still looking for strings or sequences of bytes that are running in memory. Threat check can also do this using the AMSI flag, which we'll talk about AMSI a little bit more later. Stands for the Anti-Malware Scan Interface, and is the API that Microsoft has created on Windows systems for handling in-memory malware analysis. So for the heuristics and behavioral detections, these are looking at how different programs are actually running on your program, what they're calling out to, things like that, different processes that are running, and then comparing those to known bad processes and seeing how similar they are, and then alerting based on if they're over a certain threshold. These are a little bit harder to bypass in theory because it's harder to tell what they're actually flagging on. So you have to kind of guess and check a little bit to see what's actually going on. So for our lab here, what I've set up at home, I have my Windows 10 development machine where I'm actually compiling all of my payloads using a Kali box just to have a listener running, and then a Windows 10 with Defender, Windows 10 with malware bytes. These are all up to date with the most recent signatures and most recent Windows updates as well. And all machines also have all of the security features turned on, with the exception of automatic sample submission, which I'll cover why in a little bit, because it's annoying and it will ruin all of your research. So, yeah. Right. So our malware, this is a simple C# reverse shell that I got from revshells.com. Super easy. Rev shells, you can just go on there and it'll basically list off any type of format you want a simple reverse shell in, and then you'll just spin up a listener on an attacker box. Yeah. So this is compiled in x64, and they're all named some version of probably find.exe.
Definitely maybe fine.
Yeah, not malware. All right. This is a little hard to read. Print's a little bit small here, but just so you can see, you probably find.exe right here. And this is what the C code looks like. Some of the minor changes, just changes to PowerShell. But you can see this is all this is really doing is opening up a TCP client to our Kali attacker machine, which is 10.10.15.68 on port 9001, opening up a stream and then sending commands to and receiving the output from those commands. So this is just our basic reverse shell. It's not super malicious in nature, but it's obviously a super easy first foothold that you can get on a machine. If you could get somebody to run this, then you could import your other tools or turn off AV, do what you want to do from there, right? So our initial detections, like I said, I compiled that C code and just turned it into an EXE, and then dropped it onto a Windows 10 machine running Windows Defender. Hopefully that is clean enough to see. Yeah. All right, so we see Defender goes off pretty much immediately as soon as that. That's not go here. No. Hold on, everyone look away. It's not what's supposed to be happening. Okay, thank you. Yeah, so pretty much as soon as I drop that onto disk there, you'll see we got this alert from Defender, and it's classifying it as this virtual MSIL /mouse read.a MTB. This will we'll come back to this towards the end, but you can see this is our probably fine unmodified PowerShell.exe. It classifies it as a virus or more of a malware. So it's pretty generic detection. So that is Windows Defender. And here is our malware bytes. Same thing, we take that same payload, probably find unmodified PowerShell.exe. We don't get a detection as soon as it touches disk. So I thought, all right, let's maybe go ahead and try and execute it, see if it'll alert then. So we go ahead and execute it, as you can see by this black box, because I'm a terrible programmer and I don't know how to make that go away. And we get our reverse shell on our attacking machine. So that's cool. Do a little dir just to confirm, yeah, we're running on that machine. So Malwarebytes doesn't alert on that, which is sweet.
That was a very natural bypass.
Yeah, it makes it super easy. That was my face when I actually ran that on that machine. All right, so now we can actually, that was just, show the demo of AV working, right? Let's actually get into some bypassing signature detections here. So as we saw, probably fine, unmodified PowerShell was detected by Defender. We can then go ahead and use threat check to determine what bytes Defender is actually alerting on, and then we can adjust our payload so that we can then bypass Defender. Obviously, we don't have to worry about bypassing Malwarebytes because it bypassed itself. That's fine. So this is the output of threat check. So what you do is you'll just pull down threat check, and then you can compile it, and then you go ahead and you just pass your executable to it. So what threat check does, it'll actually go through and it'll continuously have, there's a smart math word for it, I don't know what it is, but it's going to take the first half of your executable, see if there's any bad strings in it. It's going to take the second half, see if the bad strings are in there, and then it's going to continuously have until you get this chunk here, which is where it says identify any bad bytes. We'll give you the offset there. 9 times out of 10, it's going to be the very last thing that you see here. So you can see right here we have set_create no window is the bytes that we have identified with threat check. So you'll notice if you look real close at the code, I had to change over to port 9005. That's what I was saying about Microsoft. They're going to ruin all of your research. So we'll cover that here in a little bit. Cool. So we saw, pause this here. We saw that set underscore no window, right? We also have create no window right here inside of our C code. So you all you have to do, came in here, commented out that line, right? We know that that's where our no window is coming from. You can just do a control F through your code, find that string, right? We're going to go through and recompile. All right. So now we have probably fine modified PowerShell.exe. We're going to come back to our Windows 10 running Defender and drop that one on disk. You'll notice we don't get the immediate alert. And we're going to fire up our Netcat listener over here. We're going to run our executable. And then we get our reverse shell. Yeah, so just like that, we use threat check to identify those bad bytes, find out what Defender was alerting on, go ahead and change that in our code, and then we have successfully bypassed the signature detection for Defender. All right. Cool. So that gets you past that part. Next, we're going to talk about some in-memory detections. Like I said, there are different Malwarebytes has their own in-memory tool. Defender has AMSI, which is doing the in-memory portion of scanning. So we're going to walk through those a little bit. So the birds and the bees of AMSI. AMSI is a relatively new feature. Started shipping in 2015 with early versions of Windows 10. It was introduced because more malware is starting to live in memory, right? It's pretty common for attackers to either not touch disk at all, or they're going to have some sort of dropper that's going to then pull in their actual payload into memory, just for the very reason of trying to bypass antivirus, right? If you don't ever touch disk, you don't really have to worry about signature detections as much, right? So Microsoft developed AMSI, which looks at things like PowerShell, VB scripts, JavaScript, and also Office macros. So all of those things that can be used to pull things from the internet directly into memory. AMSI was developed as an API so that other AV companies can hook in and use that functionality. There's a little asterisk there just so you can keep that in mind. It's a little bit of foreshadowing there. There's tons of bypass methods though. Most of them involve patching the AMSI process so that it will fail prior to actually checking the malware. And then once you get it to fail, you can just load your payload directly into memory and AMSI won't notice. All right. There's a GitHub link to a bunch of resources on AMSI security shit. GitHub is fantastic. He has a bunch of like 3-hour long videos if you're ever interested about bypassing AV. So if you're ever curious, if you just want to check if your AMSI is running, you can pop open a PowerShell window and invoke Mimikatz. That's one that you're pretty much guaranteed to get an alert on. And you'll see this little looks like a PowerShell error, but you'll see it says this script contains malicious content and has been blocked by your antivirus software. It's a super easy way to just test if AMSI is actually running. But that's what an actual AMSI block looks like, right? So again, that's essentially because it's just doing string matching, and invoke Mimikatz is going to be on that list of bad strings. All right, so now we got a little demo here. This is our Windows Defender machine. So a little setup for this one. This is after we've run our payload and we have a reverse shell running on our Kali machine. We're then going to try and use PowerUp, which is a privilege escalation PowerShell script that has a bunch of different methods in it that you can call to try and get either local admin or system privileges on a machine once you have a user shell, right? This is one method you can use to load something from the internet into memory using PowerShell. So you'll see we have a little PowerShell prompt here. Then you're just setting a variable with your URL. Then we're going to invoke expression and do that web client. We're going to call that URL. And that's just downloading that powerup.ps1 that's being hosted on that server, pull it into memory. So then we're going to try and run this find-path DLL hijack, which is one of the functions within PowerUp. you'll see we don't really get any return from that. You'd expect to see some output from the Find Path DLL hijack. One of the issues with this simple reverse shell is that you don't get error messages, which is pretty common in the reverse shell. So I pulled up PowerShell just to show what was going on. Here we're running the same command, setting that URL, and then pulling it down, and you'll see we get the script contains malicious content that's been blocked by your antivirus software. Right? So that's a privilege escalation technique that's being blocked by AMSI with Windows Defender. Okay. So here we're going to go through and do the same thing with malware bytes. Same setup, probably fine, it's already running. We have our listener going, we're running PowerShell, call back out, pull that down into memory again. You gotta watch me type this out really slow because I fat fingered it about 10 times before this and was ready to throw my computer away.
You don't need to move the computer, you just need your fingers.
Yeah. And it's like it's a terrible reverse shell, so you can't even like back arrow. You just the whole thing. All right, so here we go. We're gonna try and run that find path DLL hijack, and we get output, which is sweet. So yeah, it worked. Malwarebytes doesn't use AMSI. Yeah, so fun fact. I had to keep asking myself, did I accidentally turn Malwarebytes off? The answer was no. It just doesn't do anything. So take that into consideration. I'm not telling you not to use it, but you know. So for the rest of the demo, we're just going to ignore Malwarebytes because it's hard to bypass something that doesn't detect what you're trying to bypass it with. So yeah, moving forward, it's just going to be Defender, essentially. So we have two different ways we can bypass AMSI. First one's going to be using threat check, very similar to how we did with the signature detection. And then the second one's going to be a little bit more advanced, but easily Googleable, and that's reflectively patching AMSI so that it fails, kind of like I mentioned before. So the threat check method, like I said, we're going to be using the -E AMSI flag while we're running threat check. And then kind of have two different options. You can either obfuscate whatever threat check finds, or you can go ahead and just remove the functions, which is what I did because I was only trying to use the find path DLL hijack function. So that's the only one I actually cared about. So here we have, sorry, it's a little small, kind of hard to read, but running threat check again with the -E AMSI flag on our ES1. It's going to go through and pull down chunk it up the same way, this time in memory though, and then find those bad bytes. I'm just going to fast forward here because for some reason this detection took a really long time. Bring it back a little bit. All right, cool. So then you'll see we get this super long string of A's here at the end. All I did was open up Notepad, do a Control F, find a long string of A's. Sweet, we got a long string of A's. That looks like it matches our output. Yeah, there's a ton of them in there. So then I'm just going to go through, highlight, delete the function. I don't need to use that function. If you really wanted to, you could go ahead and change it. modify it, obfuscate it, so that then you could go ahead and use that function. We're gonna go ahead and skip through that. I'm sure everyone knows how to delete that. So same thing again. I'm just gonna skip through this. Like I said, these detections were taking forever. Same thing, it's gonna hit on another one. Same thing, go in, find it, delete the function, rinse and repeat until until you can run AMZ and it won't flag anymore. It's the same one again. Sorry, it's really hard to tell when it switches to the next slide and when it doesn't. This is the same one. There we go. Cool. So yeah, you'll see I had to run it a couple more times. It would find different strings, go in, delete those functions that the strings are in. Till eventually, you go ahead and you'll run threat check, the AMZ flag, and you'll get no threats out. Cool. So now we know that our powerup.ps1 doesn't have any bad strings, bad bytes in it anymore. So, yep. Cool. Oh, I wanted to show this is actually Defender alerting on threat check, not on the script itself. Cool. So now we're back where we were before with our reverse shell running on our Windows Defender machine. We're going to do the same process where we pull our new and improved. By improved, I mean just add a bunch of functions, delete it out of it. PowerShell, we're going to pull that into memory. Sorry.
With all those groups of 16 A's, how did you find the right one?
I just deleted the tag function. I'm only using the find dash path URL hijack,
Right.
which none of the bad things were in that function that I wanted. Let me touch on that real quick. Yeah, so like I said, I had automatic sample submission turned off. So that's why you'll see we got this Defender requesting to submit this AMZ detection, which is coming from powerup.ps1. It's essentially whenever Defender sees something that looks a little bit suspicious, but it doesn't have a direct signature for. Normally, if you have automatic sample submission turned on, it's just going to send that up to Microsoft. Microsoft is going to analyze it, and then they're going to say yes or no, this is malicious, right? Especially when you're doing like malware analysis stuff, you usually want that turned off. So we hit don't send on that. Even if they did send it up to Microsoft, this would still work. It's not like they immediately recognize it and then shut it down. Yeah, so we'll see here, that was our new powerup.ps1. Go ahead and run it and we get our output. Now we have a potential privilege escalation via DLL hijack. All right. So that's our first AMZ bypass, which is just the signature type of going through and deleting bad strings. All right. Next method is going ahead and patching AMZ. right? So we're going to be using .NET Reflection to bypass AMZ. PowerShell is built upon .NET, which allows us to interact with the .NET framework. Part of the .NET framework allows us to load assemblies on the fly and modify them. This is what's usually referred to as reflection. You're going to go ahead and use PowerShell. You can then load in the assembly, which is what they just call basically functions, right? So .NET's built on a bunch of different functions. You can load those functions and then you can modify them and then change them. They will still run. Like I said, I'm not a programmer, so if I just said something stupid there, feel free to correct me. You know, this does work though, so I think I got it right. So this, like I said, pretty easy to Google. There's a bajillion AMZ bypasses out there. Usually anything that you pull down isn't going to work straight away. So this is the unobfuscated AMZ bypass. You'll see here at the top, we're using the reflection assembly get type system management automation AMZ utils, get field AMZ init failed, non-public static set value null true. So this is actually loading in the AMZ function within .NET, and then it's going to go ahead and change this AMZ init failed value to true. I'm sure you can see where that's going, right? Because all you're doing is you're telling AMZ, hey, you failed to initialize, and then AMZ says, oh, yeah, okay, you're right, I did.
It leaves you.
Yeah. It just says, yeah, you're right, I failed to initialize, you're free to go, right? So this is our obfuscated one. I got this one off of, I think, somebody's Medium blog page, Gustav Shen. That Medium blog post had this, where it's just a little bit obfuscated. It's still doing the same thing, right? But you're setting some variables, assembly.get types, looping through them. If name is like utils, setting some more variables. Basically, just trying to bypass AMZ or bypass any string detections that would be alerted in the top one, right? At the time that this post was written, that obfuscated one worked. So I pulled it down, tried to run it. So here, running in both Mimikatz, you'll see the script contains malicious content, just to prove that AMZ is running. We're going to go ahead, paste in that one that we just saw on the slide. And we get the script contains malicious content, right? So what's important to note here is that AMZ is using itself to protect itself, right? AMZ is looking for malicious strings and then preventing you from bypassing AMZ by finding those malicious strings. So all you have to do is get around those malicious strings and you can turn AMZ off. All right, so like I said, string matching for PowerShell. With a little PowerShell magic, we can go ahead and fix our problem. By magic, I mean, like, you don't go do post folders out of this year because I'm not that good at PowerShell. So all we did is we set $secret, set that variable to the ref.assembly.get types, which was the first portion, and then we just do $z equals that, and then pipe in the rest of it. Okay. I'll show this here in the video, show them side by side as well. So you'll see we have that $A equals ref.getAssembly.get types. Same thing, just prove AMZ is running right now. In both Mimikatz, the script contains malicious content. Then we do $secret equals exactly this part right here. And we do $Z equals $secret, and then we left all the same, substituting the Z's for A's. Cool. And we get our return, no error message. We go ahead and run invoke Mimikatz again. And this time we get the term invoke Mimikatz is not recognized as the name of a command lint, which just means that PowerShell doesn't know what function you're trying to find. So it's not being detected by AMZ. So just like that, what we did, went in, reflectively patched AMZ so that it immediately failed as soon as it went to go and check those strings, and then we are good to go. Cool. Yeah, so then next part here is bypassing heuristics. With a question mark, because it's sometimes, like I said, it's you're kind of guessing at what's causing the problem and then hopefully fixing it, right? So a little story time, what I alluded to throughout this entire thing. I started working on all these slides and these demos probably 3 weeks ago. Just working on it a little bit every night. Everything was working fine. When I went commented out the no window line, left it on port 9001. Thursday morning, I sat down, or not Thursday morning, Sunday morning, I sat down to start putting everything together. Just wanted to test everything out again. And I dropped the probably fine.exe onto disk, and it immediately got smacked by Defender and detected as whackattack.b exclamation ML, right? So super awesome. Turns out I went back onto my dev machine and I had automatic sample submission left on. So the entire time that I've been getting shot up to Microsoft, and then they started alerting on my payload. So that's why I went in, like I said, on the other one, I had to change it over to port 9005. Turns out all it was looking for was the outbound connection on port 9001. So as soon as I did that, everything worked fine. Sat down on Monday to start working on this again, and port 9001 started working again. So it was, I got put in timeout for a day, essentially is what happened. No, I'm going to keep doing it. So yeah, so you'll see I ran a corrupt check against the probably fine modified. This was the one on port 9001. And it just returns file is malicious, but couldn't identify bad bytes. So Defender's alerting on this. I can't tell you why though, is the answer there. So that's kind of just an example of the heuristic bypass. It's super simple and stupid. Yeah, but like it's easy because this payload is only doing one thing, which is creating that reverse tunnel on port 9001. So it's pretty easy to just say, yeah, it's probably looking at that port, you know. Go ahead, change that and you're good to go. Obviously, all of this stuff becomes way more difficult the what more complex your piece of malware is. So if you're trying to get a C2 agent or something to run, you're going to have to do this times 20, you know, because there's 20 signatures written, or it's looking at all kinds of different signatures or actions that that piece of malware takes and alerting on those. Yep, so here I showed just changing port 9001 and port 9005. Worked just fine. All right. Are we on time? Yeah, a little bit. Yeah, so that's all the very basic bypassing of everything. This is more of the research that I've been doing, trying to really nail down like where these signatures come from. You see a lot of this comes from research from other people. I'm not that smart, so I don't do a lot of my own original research. I just read other people's posts about things. So this is all going to be focusing on Defender again, but so your signatures are actually stored on disk with Defender. They're stored in C program data, Microsoft Windows Defender definition updates, and then you'll have a unique ID of whatever version of Defender you're running. There's a MPA-base.ddm, MPA-v-base.ddm, and then there's mpengine.dll. MPAS-base.ddm is your anti-spyware definitions, and your MPA-v-base is your antivirus definitions. And then mpengine is what's actually used to call the functions within both of those and search for the signatures within those. So using a tool called WD Extract from Firefox, just pull that off of GitHub. You can actually take these files and you can decompress them, and which you'll see you end up with a list of signatures over here on the right. This is inside of a hex editor. So you can just pull all those apart, and you'll see right here is this mouse.a exclamation NTB, which if you remember all the way from the beginning is that alert that we got from Defender when we first ran in our payload. All right. So inside of those signatures, all of these bytes actually mean something. So this is for that same mouse.a exclamation MTB. So you can actually break this down into what is the actual signature and what is just metadata for this, this signature type. Right, so you'll see we have here 5C right here in hex is equal to 92. When you go through and you actually can reverse engineer that mpengine.dll, it has a bunch of case statements in there. So it's going through and it's checking, does it match this? It's this type of detection, doesn't match this, it's this type of detection. So the case 92 is the signature type threat begin function. So then it will tell mpengine.dll, this is where we're actually starting the function. And you'll see this hex 25 right here, which is equal to 37. So that's the next 37 bytes. This is the type threat begin, and they'll give you the name of the detection right there. Then you'll see down here, this is after the 37 bytes. Then you'll get signature type sig tree, which I'm not 100% sure what that actually means. Some of these, a lot of them will see signature type static. I believe that means this sig tree is a static definition. Unfortunately, pretty much all of this is completely undocumented by Microsoft, so you have to go in and pretty much reverse engineer all of these things. And like I said, people way smarter than me are working on this, so this is where we're at and kind of why I'm stuck on this and hopefully make some progress in the future. But yeah, so that's pretty simple, and then you just go through and the next 101 bytes are your actual sig tree there. Then you'll see down here after that you have 67 signature type static, and then you'll have your static definition for the next 22 bytes, and then signature type end, which is how they all end, and then it just tells mpengine.dll that this is the end of the signature. So like I said, the exact definition or the exact thing that Defender flags on is this virtual MSIL mouse.a exclamation MTB. That one is actually found in MPAS-based.vdm, whereas what I was just showing was MPAV-based.vdm. MPAS doesn't follow the same format, and no one has been able to, either no one has figured it out or no one has documented how MPAS-based ties into MPAV-based yet. So you'll see these are much smaller. You have potentially an application block, Kubo, whatever this is, and then it's only like 16 bytes of some sort of signature or definition, and then it moves on to the next one. So I have had success bypassing static signatures with this method before, where you can actually pull up MPAV base, find the static signature, it'll give you those exact bytes. You can then search for those bytes inside of your payload, change those bytes, and then you will be able to bypass Defender. So it does work. It's just there's a lot of undocumented functions within there. Need some more research still. I think there's 175 different case statements or something within that mpengine.dll. So there's like 4 of them that people have actually documented. So yeah, that's pretty much where I'm at. That's where I've left off. So it's going to be trying to figure out the MPAS space and figure out how those all tie in. Yeah, so any additional materials, if you're interested in any of this stuff, here's a bunch of good ones. Like I said, security shit on GitHub. There's a ton of great videos. Firefox and Mogi on GitHub. Camille on GitHub are where I got a ton of the info for the MPAS and MPAB base.vdm. So that is all I've got. That is some very basic how to bypass antivirus and a bunch of info you probably didn't want to know about how antivirus works. So, that's it.
Does anybody have any questions? You were doing the
Threat check.
Threat track. You had the AMT version and you had the on disk version. What again was the difference in how you told it to just check memory versus?
Oh, yeah. It's just a flag. So it's the -E, which stands for engine. There's a couple different ones you can run. I can't remember what they are, but that one was -E and Z. By default, it's going to run just the signature detections.
Is there something like good documentation out there for what those other ones would be?
Yes, it's in the threat check. If you go to the GitHub from Ross to Mouse, it'll document I think there's 4 of them. I can't remember what all the engines are though, but it lays them all out there in the usage docs.
When you're playing around with C# code, you try setting the ahead of time compilation flag to get it compiled on the machine code versus being in the language?
No, I did not. Like I said, this was kind of like just a bare minimum of like, let's see what it takes. It didn't take a lot, so I didn't push it any further. Like I said, this is super basic reverse shell. If you were trying to do something else, you can start compiling the different flags and different architectures and things like that. But I just didn't need to for this payload.
How are you incorporating this into your work?
Probably not, but I think, especially I do more defensive stuff, right? But if you can really understand how your tools work, you can really understand how your tools can fail, which I think is just as important as knowing how they work, right? So just like you've seen here, bypassing AV, not super complicated, right? I can watch a couple hours of YouTube videos and learn how to do it myself. Somebody who's a lot smarter than me is going to do it a lot better, right? But that just kind of points out, things like EDR, having a layered approach to security so that you're not solely relying on antivirus anymore. It's not going to cut it nowadays, right? Cool.
Does Malwarebytes detect EI card? Just curious.
I think so. I hope that might be I would like to pull open their definitions and maybe it's just the ICAR in there or something.
That's the only one.
It's like our different language.
Yeah.
And then of course embedded malware.
Yeah. And then here's all of our ads,
Yeah.
It's the function that detects ICAR and then the function that runs their pop-ups every 15 seconds.
I wonder if Defender would detect Malwarebytes.
No, it doesn't.
Well, thank you so much. This was really good.
Yeah, hopefully you learned something. If not, hopefully you laughed a little bit. I don't know. Cool. How do I turn this thing off?